Welcome, ladies and gentlemen. I'd like to introduce you today to Professor Matthew Collin from Newcastle University, who's going to talk to us about his latest piece of research. Hello, Matt.
Hi, Lynn. Thank you for inviting me. Yes, we're really excited that a paper has been published in Science Immunology just Friday gone in collaboration with our friends Florence Ginu and Eglo Federaiti. And this is a collaboration that looks at the formation of the lesions of Langerhans cell cytosis, which, as you know, can be quite destructive. They can erode bone. They can cause all kinds of problems around the body. And really the question that we were trying to tackle is, how do cells that carry mutation that probably arises in the bone marrow, how do those cells come together and form a lesion of LCH? Because the lesion itself contains many different cell types. And this first slide just shows the complexity of the white blood cell system. And we don't need to spend too much time on the details of this, but there are many different types of white cells, and there are even different types of this rare cell called a dendritic cell that's related to the formation of histocytosis. And what we looked at are these red cells, DC2, these orange cells, DC3, and the monocytes, which are shown in black. And it seems like all three of these cells can contribute to forming an LCH lesion. And just trying to change the slide. Oh, here we go. This shows when you put these cells in a dish and give them stimulation to Burbeck granule, that is the hallmark of a cell with Langerhans cell type properties. So these were the things that first linked LCH to the Langerhans cell. And each of these cells, the DC2, DC3, and the monocyte, can make these little tennis rackets and contribute to the LCH lesion. And what we were trying to find out is, what conditions do these cells require? Because they're all slightly different. And the real discovery was that this DC2 here in red already expresses a little bit of Langerhans. So it likes to be a bit like an LCH cell, a bit like a normal Langerhans cell. But it also expresses the signaling molecule called Notch. And Notch does this very important thing to DC3 and monocytes, in that they don't normally express Langerhans. They don't look very much like LCH cells. But when they get this Notch signal, which can be provided by this DC2, which is already present in the tissues, they then start to express Langerhans and look like LCH cells. So the important finding is that the lesion seems to grow as a partnership of several different types of white blood cells, all kind of ganging up together and making this abnormal kind of pathology. And I think the exciting thing about this is potentially this Notch signal that seems to be intrinsic to the lesion is the kind of thing that people have developed drugs for in other types of cancer. So we don't have anything ready for histocytosis right now, but this is a new potential target that if we interfere with it, we'll be able to essentially make the lesions of LCH go away.
Matt, would we normally have these three cells in our body anyway?
Yeah, so these cells normally circulate in the bloodstream, and they're normally protecting us from infections, going into the tissues and looking out for bugs and viruses and things. But of course, they don't normally have mutations, and it's the mutation in LCH that makes them behave abnormally. So it's a good point. They only do this when they're also carrying a mutation. But we know that not just the mutation is kind of required to make the lesion. Other things have to come together to make this destructive thing that can erode bone and infiltrate organs and cause liver failure and all those kind of things. And this mechanism seems to be one of the ways that the cells talk to each other to turn them from just being cells in the blood carrying a mutation to actually causing pathology.
So would it normally be a case of trying to interrupt these cells then from getting together?
Yeah, exactly. It's kind of, we need to this gives us a potential way to break up the party. When individually they may not be able to do what they do in an LCH lesion, but when they get together, that's when they cause trouble. That's kind of an assumption, but at least when we look into the lesion and we find pathways that are kind of involved in creating the pathological cell type, we then it's a reasonable line of study then to try and interfere with those pathways, hoping that they will make the lesions go away. But I guess we wouldn't know that until we test it with drugs. But it's another kind of hopeful avenue to explore.
Matt, is this something that is only paediatric, or does it also affect adults?
I think it's a good question. So if you ask the pathologist, they wouldn't be able to tell what age patient the lesion came from. So they potentially all look the same in children and adults. Most of the samples in the study were taken from children, but we would assume that the same mechanism is occurring in adults as well.
At this time, do we have the ongoing research to further this course?
It's a very exciting time. There's lots of things happening in LCH, and I think this is this all stems from the discovery of the mutation that causes the LCH. So it's kind of the next question is, we know that mutations are always present, but what we're in the process of doing is filling in the detail to explain how the mutation causes the lesion. So, it was a very important discovery based in between that we're now filling in, which is how the mutation actually causes the disease. So I think it's something that lots of people will be interested in.
Does this then feed on, Matt? Is this the before or the after of the knowledge of the BRAF gene?
It's the after. It's filling in the mechanism, how the BRAF gene causes the lesion.
Right. So at this time, is the patient going to be sort of really sick, or are we looking at something that is going to prevent them from being that ill?
Potentially, this is something that, well, I guess if you're a patient, you don't know this is going on until you have a problem and you've got a lesion, and then you come to hospital with a painful bone or a lump or something like that. If we had drugs to interfere with this pathway, this might be something that we could do to make the lesions go away in the first instance. And the kind of thing where it might be useful is that at the moment we use chemotherapy and we use steroids, which are both potentially toxic drugs. So although they're very effective, if we have new sort of molecular pathways that we know are involved, then potentially we can use drugs that are more targeted to a specific mechanism inside the lesion, but won't necessarily interfere with other processes. So, for example, if you take steroids, it's hard to sleep, you eat lots, you gain weight, it's bad for your bone density. There's a whole load of metabolic side effects, and that's very effective in making a lesion go away. But perhaps we could be smarter and target the exact thing inside the lesion that was making it happen, and that drugs that do that might not have so many side effects. I think that would be the goal.
The drugs that we're using at the moment are probably drugs that are used in other tumours?
Yes, most of LCH therapy is borrowed from other cancers. That's kind of a necessary thing in a rare disease, because people are happy to give drugs that they've got experience of giving. Also we're quite fortunate in terms of BRAF mutation that there are drugs that are targeted to that specific pathway that were developed for other cancers. So it's not that we're just collecting the crumbs off the floor. We do really benefit from all the activity and research that's done on other tumours where there's a similar mechanism. So BRAF is found in other tumours, notably melanoma. So we benefit from all the drug development in melanoma. And we also know that Notch is a target in some other cancers. So there is interest in developing drugs too much.
My final question, Matt, what are your hopes for research in the future years?
Well, I would love to have, it would be great to have more discoveries like this. I think, well, there's plenty of unmet needs and plenty of priorities. One thing that everyone is very conscious of is we don't have a good strategy for getting off the drugs that are targeted to BRAF mutations. So we need clinical research to try and figure out how we can actually cure people who are on inhibitor drugs. Because at the moment, if you stop taking BRAF inhibitors, the disease is likely to come back quite quickly. So it would be nice to have a so-called exit strategy. And then on the basic side, we really need to understand what's going on in neurodegeneration, which is a thing that many people are worried about. Fortunately, it only affects a small number of patients, but we really don't understand the mechanism of neurodegeneration. And that's something that we'll be trying to focus on in the next week.
That does take me to one other question then, Matt. The information that you're gathering on the UK HR registry, the United Kingdom Histiocytosis Registry, this new information that we have here, will you be looking on that registry now for these indications?
It helps. The registry is very clinical, so we're very grateful to people agreeing to participate, so that we can follow their clinical progress. We can see what treatments they've had, what problems they have. That's kind of defining the extent of the clinical problem and the pain and discomfort that the disease brings. That's all the essential groundwork or description of the landscape of the disease that we need in order to decide where we do our research. Another thing that does help is that we can't do any of the research without samples. So if we have people on the registry, we can ask them for a blood sample, and we can also get access to their pathology that's stored in the path lab to do these kind of experiments. So some of the work in this paper was used pathology samples that were stored with sort of very sophisticated microscopy, much more complicated than the sort of normal diagnostic thing. So that the registry is a kind of essential thing to have, A, to know what the problems are, and B, to get access to the samples so that we can do this kind of basic research.
Thank you, Matt. On behalf of us all at Histio UK, thank you for joining us today. Ladies and gentlemen, Professor Matthew Collin.
Thank you very much.